Isoflavones are known to decay exponentially if a 500-gram sample has a half-life of 20 years. Find out how much will be left after 30 years. I don't know what isoflavones are. I was told they're an amino acid, but since I never did well in biology or chemistry, I have no idea what that means. Yeah. All right, so we have this equation. There's one thing we do not have or we're not given in this problem. What is that? K. We do not know the rate of decay. So we can't answer this part, how much will be left after 30 years, until we figure out the rate of decay. All right, so that 30, ignore it for now. But in the meantime, we need some other numbers in here. 250 for what? Good. So that means we'll end up with 250 when we start with 500 e to the negative k times, and when does this half-life occur? 20 years. So this one's trickier than the previous one, times 20. So k times 20. So your exponent would be negative 20k there. All right, this is an exponential equation. We need to solve for the exponents by involving logs, but we don't do that just yet until we do what to both sides? Divide by 500. Doing so gives you 1/2 equals e to the negative 20k. Take a second, solve for k, leave it in the exact answer sans decimal. So use a log. What type of log are we going to need? So the natural log of equals. So to solve for k, we're going to divide both sides by negative 20. So the exact value of k would be natural log of 1/2 over negative 20. Don't round this, because if you do, the rest of the answer will be off. So we found our k. So we're going to use that k in the initial problem now. So P of t will equal 500, because that's how much we're starting with. E to the negative, now put in your k, natural log of 1/2 over negative 20. Sorry, that's so small. T. 500, natural log of 1/2 over 20, over negative 20. I'm sorry, let me say that again. 500 e to the negative natural log of 1/2 over negative 20 t. If you want, you can clean up your double negative there. It's up to you. But how do we finish this problem? Put 30 in for t. I'm going to clean up that exponent a little bit. So natural log of 1/2. Now this is what you carefully throw into your calculator. And if you would, let's round this to 2 decimal places. Oh, not yet. Please be careful with your decimals there. Since we're asking for a period of time that's longer than the half-life, then we should expect a number that's what compared to 250? Less, smaller. What do you get for P of 30? $176 point. Sure. And what's the unit here? Careful. Grams.